we want to determine the simple interest rate. So this time we're finding R, at which, so let me do R equals our question mark, at which 12,000 or 1,200 is going to grow to 1,250 in 8 months. Okay, so we're starting at $1,200. We want to finish at 1,250, and we know it's going to take 8 months, or 8 months out of 12, in order to convert that to years. Okay, so we need to have that in years, and this time we're going to find R. So A equals, using our formula, because we have simple interest, so A equals P times 1 plus RT. 1,250 is equal to 1,200 times 1 plus R times 8 over 12. Okay, so let's divide off the 1,200. Cancel that out. And if I just reduce this fraction over to the left, I'm going to wait and kind of plug it into my calculator all at once so I don't have any kind of rounding error. But if I reduce the 1,250 over 1,200, you'll get 25 over 24 is equal to 1 plus, basically, so R times 8 over 12. Okay, so let me come down here in the bottom. We want to take 25 over 24, obviously subtract 1, and that'll get me R times 8 over 12. And then all I have to do is divide both sides, or here we can maybe even multiply both sides by 12 over 8. That way I can take away 8 and 8 and the 12 and 12, and I just get R by itself. Okay, so putting this thing on the left all in the calculator at once, you're going to go 12 divided by 8 and then times the 25 over 24 minus 1. And I get an answer of R to equal 0.0625. And if we want to convert that actually to a percentage, we're going to move the decimal now 2 times to the right. So this is 6.25%. So at that interest rate, then I know for a fact that all it's going to take is 8 months for us to grow basically $50. Okay? Let's go to example 4. All right, here we have a principal amount, so initial investment of $12,000. We have a rate of 8%, so 0.08. Our T is 10.5, so actually I'm going to probably write that as just 10.5. Okay, and we're going to compound quarterly. Ah, look, brand new. We're finally talking about the compound. So this is going to be our new formula. So let's write that new formula. It's A is equal to P times 1 plus R over M to the MT. Okay, so up there, I know P. A is what we're wanting to find. So A is going to equal 12,000 times 1 plus our R. So our R is 0.08. And look, we need to put an M in. Well, remember, M stands for the number of compounds each year. So just in 1 year, how many compounds? Well, if I'm going to compound quarterly, that's going to be 4 times in 1 year. And in this exponent, we're going to go 4 times 10.5. Okay, so if you don't have your calculator, pull out your calculator, because, again, the stuff is not very hard at all. Where you're going to get tricked up, if anything at all, is just plugging this in your calculator. Okay, so once you pause it, get your calculator out, try plugging it in, let's see if we get the same answer. Okay, so when I did it, I got then the amount of money coming out is $27,566.93. Okay, so again, how I did this in my calculator is I just typed in 12,000, I opened a parentheses, and I used a graphing calculator, by the way. I did 1 plus just 0.08 divided by 4, close parentheses, caret, open parentheses, 4 times 10.5, close parentheses. That's all I did. Okay? So let's go on to number 5. Here we have initial investment of $150,000. Our rate is 12%, or 0.12. Our T is 3. We're compounding daily, so that means my M is 365. Let's find A. Every time I do one of these, as you're going to see, I like to write the formula, because you're going to have to know these formulas. I'm not going to give these to you. So you're going to have to know them. There's not very many of them at all. So the more you write them, the easier they become. So the initial investment is $150,000. 1 plus the rate. So we're going to take that rate and we're going to just divide it down to, so we can see pretty much this fraction right here, 0.12 divided by 365. It just shows you basically what your rate is prorated every day. Up above, it was your rate prorated quarterly, so 4 times a year. And then up here in the exponent, it's 365 times a total of 3 years. Okay, again, pause the video, try to get your answer, and let's check together. Okay, and I got the amount of money coming out as $214,000, $986, $214,986.69. So hopefully y'all got the same thing. Now, before we go on though, I'm going to ask you a question then. How much interest did you earn? You initially deposited in, or you invested $150,000. What came out after 3 years was $214,000. So if I want to find the interest, all it is the difference of the two numbers, because this is the money that you gain by just letting the bank borrow your money. Simple as that. Now, how many of us have $150,000 that we can just let the bank borrow? Not too many, but especially not in college. But this is what it's showing you, is basically that if you let the bank borrow $150,000 just for 3 years at a 12% compounded daily interest rate, you're going to get $64,986.69 for free. Wouldn't that be nice to have? Because all of this is just added interest. Again, you have to, this is money that this is $150,000 you just give over to this loan or to this bank, and you just let it sit there. You don't add money to it, you don't subtract money to it, it just kind of sits there. But for 3 years, it gained $64,000, basically $65,000. Not too bad for just 3 years. Can you imagine like how much money, you remember, like as I go down to the next problem, you remember like those things, you hear those stories about how grandparents will set up a college fund. Can you imagine if they even just set $10,000 up for you guys initially, just when you're born, how much money you would have, or even $5,000? How much money would you have 20 years later when you're 18 years later when you're ready to go to college? If that money just sits there in the bank account, just earning interest, earning interest, earning interest. Definitely something to consider, that's for sure. Okay, well here with example 6, we just want to find the effective rate that corresponds to 8% per year compounded monthly. Okay, so we want to find RE, the effective rate. Okay, that's what we don't know. We know of another rate that's at 8% per year compounded monthly. Okay, I had no idea what the computer did there. Just a second, gotta get some weird stuff with the computer, but we're going to compound monthly, so our M is equal to 12. Okay, so this is another one of those times when you're like, I don't remember the formula. What's the formula? Well, the effective rate equivalent is equal to 1 plus R over M to the M minus 1. Okay, so let's just go ahead and plug it in. So the effective rate, or the comparable rate to 8%, is going to be 1 plus 0.08 divided by the number of compounds, which is 12, to the 12 minus 1. Okay, so all we have to do is just put this in our calculator, just as easy as it says. Just go 1 plus 0.08 divided by 12, close parentheses, your caret 12, and then after that minus 1. And it looks like what comes out for me is 0.08. If I round it, it says 2999, so let's just do 83. So then our effective rate is 8.3%. So 8% compounded monthly is equivalent to 8.3% simple interest. And this is a simple interest rate. Okay? Well, let's look at example 7. We want to find the present value of $40,000 due in 4 years at 7% per year compounded monthly. Okay, so we want to find basically is, I don't know the present value. All I know is that $40,000 is due at 4 years with a rate of 0.07 compounded monthly. All of that right there, that's how you word it all out. So this scenario would be something like, just know like you're going to be borrowing some money, and that you know you're going to have to pay $40,000 in 4 years. So it's like, how much do I need to set aside today that when it sits there in the bank for 4 years, by the time the end of that fourth year comes around, that the balance in that account is exactly $40,000. Okay, so you can think about it. Maybe if by the time you go to college, you know, at the very end of your 4 years, assuming you could just wait and pay at the very, very end. Let's say at the very, very end, you owed $40,000 to the school. Then what we can look at is, what do I need to set aside today at the very beginning of my 4 years? So that way, by the time it just sits in that account and just earns interest, I can just write a check and it drains that account, but it's exactly for the $40,000. Okay, so A, using my compound interest formula, is P times 1 plus R over M to the MT. So A, I already know. I need $40,000 to come out. P is what I'm going to put in. And obviously I'm going to put in a smaller amount, hopefully. 1 plus 0.07 divided by 12 to 12 times a year for a total of 4 years. Okay. So really, just to solve this, I'm basically going to take $40,000 and divide it by whatever comes out right here, right? And do the same thing over here. So 1 plus 0.07 divided by 4, all of that, and I'll just go and write that as 48. Okay? So that's going to take all of that away. And you want to practice in your calculator real quick? Okay. And when I put this in my calculator, what I do is I get a p-value of $17,394, and I'll round that to 34 cents. Okay. That's not bad. Look at that. If you put away $17,000 today, and you can find a bank that'll offer you 7% per year compounded monthly, all you have to do is set aside let's say you're a brand new freshman, $17,000 right now to have $40,000 after 4 years. That is not too bad, but then again, you have to be realistic. How many of us actually have $17,000 we can give up? But still, find yourself somebody that win the lottery or something like that, and you get the money that way. Okay, let's look at the next example.